All right, the last two pages of these notes are basically a bunch more examples, so let's get right to them. Okay. All right, next one. 2/3 times x plus 4 quantity squared minus 12 equals 0. So we want to get the squared part by itself, so we'll start by adding 12 to both sides. Okay, so then that gives us 2/3 times x plus 4 squared equals 12. Okay, next we want to multiply by the reciprocal of this fraction to get rid of it, so that's 3/2. Which, don't worry about fractions. That just tells us to multiply by the top number and divide by the bottom number. It doesn't matter what order you do it, but those are going to cancel, which is good. It's what we want. And then we get x plus 4 squared equals, and then 12 times 3, 36 divided by 2 is 18, or 12 divided by 2 is 6 times 3 is 18. But either way, we get 18. Okay. Unfortunately, it's not a perfect square, which is not ideal because our next step is taking the square root of both sides, but that's okay. That gives us x plus 4 equals, don't forget the plus or minus anytime you take the square root. And then we got root 18, but we want to simplify that if we can. Well, 18 is 9 times 2. The square root of 9 is 3, so we can take out a 3. And we got the root 2 part left over. Okay. And then the last step is just subtract 4 from both sides. And then, let's get this over a bit, that gives us what? So that leads to, our answer is going to be x equals, and that's going to be negative 4 plus or minus 3 root 2. And then anytime your answer has a radical or pi or something like that in it, you can just leave your answer like that. Okay, so then that's our solution. All right, now next, solving quadratic equations in other forms. So here we got 5x squared minus x minus 6. Okay, so this one's multiplied out. In other words, it's in standard form, not descriptive form or vertex form like we've been dealing with a lot. Okay, so then how can we solve one like this? Well, you have some options with quadratics. You can use the quadratic formula. You can complete the square. You might be able to get the squared part by itself and take the square root of both sides. Or you might be able to factor. Okay. Well, we can't get the squared part by itself because then we'd have x on the other side of the equation. So then that's out. We don't want to complete the square. Most of you guys probably forgot how to do that anyways. So then should we use the quadratic formula or factor? Well, this is where you have a choice. You can try to factor, but what happens if this thing isn't factorable? If it's not factorable, then you just wasted your time, right? So we can use the quadratic formula. We know that will always work. Okay. Now, to help you remember the quadratic formula, the best thing to do is just write it down. But there's a little story to help you remember the quadratic formula. So just remember, the negative boy couldn't decide whether or not to go to the radical party, so he decided to be square and missed out on 4 awesome chicks, and it was all over at 2 a.m. Okay, so silly little story. There's songs, there's just, photographic memory is nice too. But anyways, you need to know that formula one way or the other. That's very important. Okay, so again, this might be factorable, but I don't really want to deal with the leading coefficient anyway, so let's just use the quadratic formula. Now, before you plug numbers into the quadratic formula, make sure that it's in this order and it's equal to 0. Otherwise, it won't work. Okay, so our a value is 5, our b is -1, our c is -6. So negative b is going to be -1, so that's +1, plus or minus the square root of b squared, which is 1, minus 4 times a, which is 5, times c, which is -6, all over 2 times a, which is 2 times 5. Okay, and then we want to simplify that. We want to simplify under the radical first. That part's called the discriminant. Okay, so that's going to be 1 plus or minus the square root of 1 minus, and then it's going to be minus a negative number, so it's going to change it to a plus, and then 4 times 5 is 20, times 6, 20 times 6 we get 120, which gives us 121. Sorry, I'm thinking of the total already. 120, we didn't add it yet. Over 10, okay? And then 1 plus 120, we get 121, so 1 plus or minus root 121 over 10. And then fortunately, that is a perfect square. So we're going to work to the right because we got a little bit of space there. The square root of 121 is 11, so we get 1 plus or minus 11 over 10. Okay? And then last thing we want to do is what are our actual answers. Okay, so 1 plus 11 is 12 divided by 10. I get 12 over 10, which reduces to, I'm sorry, I didn't write x equals, but that's okay. So 12 over 10 reduces to 6 over 5. And then 1 minus 11 is negative 10, divided by 10 is negative 1. So my two answers are 6 over 5 and negative 1. Okay, now a little hint. Since the discriminant came out a perfect square, what does that tell us about this equation? Well, it tells us that it was factorable. Anytime our equation is factorable, you're going to get a perfect square under the radical. Okay, which makes doing the quadratic formula easier for problems that are factorable. Okay. All right, anyways, that's that one. Let's take a look at the next one over here. Okay, now on this one, like it says, it's not set equal to 0 yet, so that's the first thing we got to do is set it equal to 0. Now, we also don't want to just subtract 1 next to these two factors here, so we got to do two things. We got to multiply this stuff out and then subtract 1 over. If we multiply this stuff out, we will get x squared. Let's try to separate our two problems here. We get x squared plus 5x plus 4 equals 1. And then when we subtract 1 from both sides, we get x squared plus 5x plus 3 equals 0. Okay, so whether we're going to factor or use the quadratic formula, we always want to set equal to 0 first. Okay? All right, so is this one factorable? Well, does anything multiply to 3 and add up to 5? No, so it's not factorable, which means we pretty much want to use the quadratic formula. Okay, so let's scoot over here to the right and we'll plug it into the quadratic formula. Our a value is 1, our b is 5, our c is 3. So we're going to get negative b plus or minus the square root of b squared, which is going to be 25, minus 4 times a, which is 1, times c, which is 3, over 2 times a, which is 1. Okay, then simplifying that, we get negative 5 plus or minus the square root of 25 minus 4 times 1 times 3. That gives me 12. So 25 minus 12, we get 13 over 2. And then since we can't simplify root 13, well, that's good. That means we're done. That's our answer. Okay, so the quadratic formula is not always that bad. Okay. All right, moving on. Next one, 3x squared plus 2x minus 6 equals 0. Okay, so good. This one's already set equal to 0. Is it factorable? Well, it's hard to tell because of the leading coefficient. So it might be factorable, but we could try to factor it, and we might just be wasting our time. So the safe bet here would be to use the quadratic formula again. Okay, our a is 3, our b is 2, our c is negative 6. So we get negative b plus or minus the square root of b squared minus 4 times a times c over 2 times a. Okay, and then we want to start simplifying, so we get negative 2 plus or minus the square root of, let's see, this is going to be 4 minus a negative, so 4 plus, and then 4 times 3, sorry, 4 times 3 is 12, times 6, we get 76. Sorry, 72. I was thinking ahead again. Over 6. And then, like I said, that's going to give us 76. So negative 2 plus or minus the square root of 76 over 6. Okay. And then we want to simplify if we can. And then, yeah, we can simplify this. So let's see, that's going to be negative 2 plus or minus, that's going to be 2 root 19 over 6. And then I can divide all three parts by 2. So let's reduce. This is going to become a 1, this is going to become a 1, and this is going to become a 3, which gives us our final answer of negative 1 plus or minus. You don't need to write the 1, just root 19 over 3. Okay. So a little bit more, sorry about that. off screen a little bit more algebra steps on that one, but there's our answer. Okay. Also, if you need to simplify something like this, you might want to do it on scratch paper on the side. Just do the little factor tree. Say, okay, root 76, that's the same as, 2 times what, and then just keep breaking it down until you find your pairs. I'm trying to speed things up, so I just did it for us. All right, one more on this page. I know we got kind of a lot here, but I'm getting through it. Okay, on the last one on this page, first thing we want to do, since it's not set equal to 0, is set it equal to 0. There's 2 steps to doing that. One, I want to distribute the x to give us x squared minus 3x. And then we also want to subtract the 28 over to give us minus 28 equals 0. Okay, so again, if we don't want to think too hard about how should we solve, we can always use the quadratic formula. But this one's factorable, so let's do it just so we can see a different method here. And you did this on the last assignment, but if we factor this thing, well, then multiply 2 numbers and get negative 28. I got to have a positive and a negative. I got to have x times x to give me x squared. And then what multiplies to 28 and has a difference of 3? Well, 7 and 4. And the bigger one needs to be negative, so then negative 7, positive 4. And don't forget this equals 0. Well, if I got this thing times this thing equals 0, well, that means at least one of these has to be 0. So then I just want to see when do these factors equal 0. And we can do that in our head. That's an easy one. X plus 4 is going to be 0 when x is negative 4. X minus 7 is going to be 0 when x is positive 7. So negative 4 and positive 7 are our answers there. Okay, so you can see that the factoring is less writing to do. It's not always the easiest method. It kind of depends on how good you are at factoring and whether or not the question is even factorable. Okay, if you want to play it safe, you can just do the quadratic formula every single time. Just make sure you get it in this form first. All right, moving along. Got a few more on the back page. I know it's a lot of examples, but it's good for you to have something to look back on. All right. 2x squared minus 3x plus 7 equals 4. First thing we would want to do is set it equal to 0. So we get 2x squared minus 3x plus 3 equals 0. Okay. So again, is this one factorable? I don't know. It's hard to tell because of the leading coefficient. So rather than potentially wasting time trying to factor it, let's just use the quadratic formula. So our a is 2, our b is negative 3, our c is positive 3. So then we get negative b, which is positive 3, plus or minus the square root of b squared, which is going to be 9, minus 4 times a times c, over 2 times a, which is 2 times 2. Okay? Starts to simplify that, we get 3 plus or minus the square root of 9 minus, let's see, 4 times 3 is 12, times 2 is 24, so 9 minus 24 over 4. Let's go up here. So then that gives us 3 plus or minus the square root of, and then 9 minus 24, we get negative 15 over 4. Okay, so this does mean that there are no real solutions, but we can still solve using imaginary solutions. Okay, we learned last year in Math 2 to simplify this thing. Anytime we have a negative under the radical, basically that means we're pulling out an I. So then we're going to say 3 plus or minus, and since I is the only thing we can take out, it's just I root 15 over 4. And then can we reduce any more? No, so we're done. Okay. So what this basically means is that our graphs don't intersect each other, but we can still get imaginary solutions. Okay, so sometimes on your homework they're going to ask you for the real and imaginary solutions. So that's how we do it. If we have a negative under the radical, take out an I. Okay. Next one. Okay, great. This one's already set equal to 0. Awesome. Is it factorable? I don't know. Oh, also, on the last one, since the discriminant came out a number that's not a perfect square, well, that means that this was not factorable, so that's good. We didn't waste time trying to factor. Okay. Should we waste time trying to factor here? Yeah, probably not. Let's just use the quadratic formula again. Okay. So our a is 2, our b is negative 1, our c is negative 3. So negative b is going to be positive 1 plus or minus the square root of b squared minus 4 times a times c over 2 times a. Okay, we get 1 plus or minus the square root of 1 minus a negative, so it's going to be 1 plus, and then 4 times 3 is 12, plus, no, sorry, times 2 is 24, over 4, so we get 1 plus or minus the square root of 25 over 4. Okay, now, since we got a perfect square here under the radical, okay, what does that mean about this equation? Well, it was factorable. That's okay, we're almost done, and you know, it would have taken maybe a little bit of thinking and some time to factor this one. Okay, so then moving on here, we're going to get 1 plus or minus 5 over 4. And then to get my two answers, so I'm going to get x equals, well, what's 1 plus 5? 6 divided by 4 is 6 over 4, which reduces to 3 over 2. And my other answer, 1 minus 5, is negative 4 divided by 4 is negative 1. Okay, so really it didn't take us that long to get answers using the quadratic formula. Sure, it was factorable, but would it have been faster to factor? And it depends on how good you are at factoring. But anyways, we have some options there. That would have factored to, 2x minus 3 and x plus 1. Okay? But anyways, there's our answers. Let's move on to the last two here so we can wrap these up. All right, this one. Now again, we have some options. If I want to, I can multiply this thing out, x minus 3 times x minus 3, then add 7, then subtract the 13 over, and then use the quadratic formula. But that's a ton of work. Whenever we have this squared part here, in other words, if you only see x in your equation one time, whether it's x squared or x that's in a binomial squared, if you only visually see x in your equation one time, that's when you can solve using square roots. So let's do this one that way. So we want to start by subtracting 7 from both sides. So we get x minus 3 squared equals 6. And then we want to take the square of both sides. So I get x minus 3 equals plus or minus root 6. Just leave it as root 6 because we can't simplify that. And then only one more step to get x by itself. Just add 3 to both sides. And we get x equals 3 plus or minus root 6. Okay, and then since there's a radical in our answer, then we just leave it with the plus or minus. That's our answer. Okay, so a big part about solving quadratics is knowing which method is best to use. Okay, sure, the quadratic formula will always work, but it's not always the simplest. Okay, last one here. All right, 3x minus 10 equals x squared plus x. So obviously I want to get this thing set equal to 0, but we also want our squared term to stay positive. Okay, so then I'm going to move this stuff over to the other side. Okay, so then that's going to give me x squared and negative 2x and positive 10. And then does it matter what side the equals 0 is on? No, it doesn't matter. So I'm going to put it on the right side because that's where I'd like to have it. Okay, and then now we have our options. How do we want to solve this? How do we want to get this answered? Can we factor it? Well, is there anything that multiplies to 10 and has a difference of 2? No, so it's not factorable. So then I think our best bet would be the quadratic formula. Okay, so last one here, negative b would be positive 2, plus or minus the square root of b squared, minus 4 times a times c, over 2a. Okay. All right, let's try to do a little bit of mental math because we're a little short on space, at least I am. So that's going to be 2 plus or minus, let's see, 4 times 1 times 10 is 40. So 4 minus 40 is negative 36. So root negative 36 over 2. And then that's going to be 2 plus or minus, we can take out an I since it's negative, and the square root of 36 is 6, so that's 6i over 2. And then we're pretty much done. The last thing we want to do, if possible, is reduce. And then since 2 goes into all three of these things, yeah, that becomes a 1, that becomes a 1, that becomes a 3. Okay, so then that's going to be 1 plus or minus 3i over 1, which we don't need to write, so then it's just 1 plus or minus 3i. Okay, so a lot of examples there. If you guys have any questions, just make sure you ask me in class, and that's it.